So in this video, I'm going to be doing question 2 from the Spring 2020 test 2. So here we have the scenario. So suppose that the average amount of sleep per night in the student population is 7 hours. So it's like if we ask everyone, what is the average amount of sleep that they get per night, the average, and then average the responses, we'd get 7 hours, right? So the first question is asking us to just kind of think about things. So it's asking, what is the plausible value of the standard deviation of the amount of sleep per night in the student population? So the way I would approach it is I would say, okay, so what's the lower reasonable bound on how much people sleep? What's the reasonable upper bound? And I came up with, well, like probably very few people sleep less than 4. So maybe 2% is probably right, maybe even a little bit less. And I would say probably very few people get more than 11 hours per night, right? So in fact, there is a paper that I looked up. It's actually a pretty interesting paper as well about the reported the effect of sleep, amount of sleep on high-level cognitive abilities. And what I got from this paper is that I wasn't that far off. So here I was just completely making things up. So what they observed is kind of in their survey, at least, an average of 6.42. So not a lot, actually, with a standard deviation that's 1.23, which is pretty close to 1.5. So that's that. So next, the question is asking, so we intend to survey 200 randomly selected students and got each student's average amount of sleep per night and compute the average. So what is the probability that this average is greater than 7.2 hours? So we are supposed to only use p-norm with mean 0 and SD1, which means that we need to use this fact, right? So if you take x bar, so in this case, the average, subtract mu, that's the true mean, and then divide by sigma divided by square root of n, we know sigma in this case, then that's going to be normal with 0 mean and unit variance, which is the same standard deviation of 1. So that means that the probability of x bar is greater than 7.2 is the same as what we have displayed there, right? And that's just algebra. So you subtract mu from both sides and you divide by sigma divided by square root of n, both sides. But then you know that this variable is normal 0, 1. So with this one, you can use p norm 0, 1, right? Because kind of this probability, it's just p norm, so 1 minus p norm of this thing. Okay. So, okay, cool. So that means that, we get to just say, sorry, so that means we get to just say, you know, 7.2 minus 7, so 7.2 minus 7 divided by sigma divided by the square root of the number of people in the sample. That's our z. And we need the probability that that's greater than the transformed version of 7.2. So we do the 1 minus. So very similar to what we had done in precept. And we got 0.029. So next, we're asked to do the same thing, but with our norm. And again, with mean 0 as d1. Okay. So given that we already worked this out, so what I'll do is I'll generate my z's here, okay? And I'll just ask, well, how often were they larger than this thing, the transformed version of 7.2, right? So again, the trick here is to say that this is normal 0, 1, just because we know that this is normal 0, 1. So that means that we just get to say, well, like how often are samples from normal 0, 1 greater than this thing, which we already computed? This is the z. Okay, so that's going to be like that. And we're going to say, well, like how often are those greater than the z that we computed before? And that's going to be exactly the same. So next up, we are asked to do the same thing, but with a different approach. So the approach that I chose, and there were actually several, so the approach that I chose was to actually generate the sample. Okay, so here, okay, I actually cheated a little bit. What I meant to say is this is 0 and this is 1. But what we'll do is we'll multiply by 1.5 and we'll add the 7. So those are now samples from mean 7, standard deviation 1.5, because this is how you can transform variables this way, as we had done in precept. And now we ask the same thing. How often are those samples greater than 7.2? Okay, so here we're averaging the 200 samples. So each output from get sample is going to be actually one mean for a sample of 200 fake students. So that, and we get, again, the same number. So another possible thing is this, which is actually kind of similar, but here you divide by square root of 200, right? So here we're directly generating the means. So the means have mean 7 and standard deviation 1.5 divided by square root of 200. But otherwise, it's the same idea. Not going to go into detail here because I already gave another answer. So, okay, that is question 2.